All right, it's Friday, April 9th. Let's write down this pH scale real quick. 14, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Now, I just want to be sure you guys understand this because it is likely going to be on your test next week. Let's take a look at a pH of 3. And let's look at a pH of 6. What I want to know is which of those would be a stronger acid, a 3 or a 6? Derek?
3.
A 3 would be correct. Now, the next question is going to be, how many more times acidic is it? In other words, you're saying how many more hydrogen ions are there? Arshan? So if you go from 6 to 5, that's 10. 5 to 4, that's another 10. And 4 to 3 is another 10. So every time you're going up or down, it's 10 times. It's either 10 times more or 10 times less. And so you have to ask yourself, Kendall, how many zeros are there when you have 3 10s? There's 3 zeros. What number has 3 zeros, Kendall? What's that? 1,000. So what we say is a pH of 3 is 1,000 times more acidic than a pH of 6. Another way you could flip that is you could say a pH of 6 is 1,000 times more basic than a pH of 3. You're like, well, wait a minute, 6 is an acid. True. But if I don't know if I still have this saved. Yes, I do. There it is. Take a look right here. Look at 3 and look at 6. Do 3 and 6 have hydroxide ions in them? They certainly do. But which one has more hydroxide in it, 3 or 6? Hydroxide, guys. 6 does. So only when you get to 0 is it really 100% hydrogen. And only when you get to 14 is it really 100% hydroxide. Yes, Arshan? Yes. Yes, it would. So what I would like you guys to keep in mind is that acids and bases have both ions, but an acid just has more hydrogen than hydroxide. A base just has more hydroxide than hydrogen. Okay, if we were to look at your homework from yesterday, are there any rows that really stand out to you where it was tough? Did you guys understand it based on the practice ones that we did? Well, to prove to me that you do, let's see if you can recall. If I want to go from pH to hydrogen ion concentration, what type of equation would you have to do to go from pH to hydrogen ion concentration? Arshan? You would have to type in 10 to the negative pH value. So, for example, I'm not going to do the whole math here, but if I had a pH of 3.7, you would have to do the 10 to the negative 3.7. We just finished vocab quiz. You need to make arrangements to come Monday before or after school, Juliana. You would do 10 to the negative 3.7, that would be your answer. What if I wanted to go from the hydrogen ion concentration to find the pH value? What would you do there, David? You would type in negative log, parentheses, whatever that hydrogen ion concentration was, close parentheses, and that will give you your answer. Now, you do the same type of math when you're going from pOH to hydroxide ion concentration. If you went from pOH to hydroxide ion concentration, you would do 10 to the negative pOH. And if you were doing hydroxide ion concentration to pOH, you would do negative log, open parenthesis, hydroxide ion concentration, close parenthesis. And finally, what if I have pH and I'm trying to find pOH? How do you go back and forth between those two? Go ahead.
14 minus pH.
You do 14 minus pH to get pOH, Or you could do 4T minus pOH to get pH. Okay, so what I have for you guys today and what I have on your desks is a acids and base stoichiometry assignment. So I'm going to take a moment to bring that up online so I can show you how to go about this. If you finish this in class today, then you have no homework. Give me 1 second. Okay, here we go. Let's switch the view. All right, guys. The assignment is for gas stoichiometry. I will work on number 1 with you, and then you will do 2, 3, 4, and 5. You can work together if you like, but it's going to be without me. So here's what I'm going to do. I'm going to just read these, and I'm going to switch over to the notepad so I can have plenty of room to write. So part A says, write the equation for the dissociation of ammonium hydroxide, NH4OH. All right, very good. So we have NH4OH. It is aqueous. It is dissociating, which means it's going to break apart into its pieces. Now, let's see what you guys recall from first semester. How many ions, not atoms, ions are there in that compound? What do you see? Besides Arshan. Arshan, I appreciate your willingness to participate. I want to share the wealth here.
Of course. You always got me.
Okay. Somebody said too much caffeine. I saw someone raise their hand over here. Ammonium. What is ammonium, Kayla? Or not Kayla, I don't know, Alyssa? NH4. What's the charge? No. Okay, hold on. Shh. What is the charge of the first ion in every compound? Positive or negative? It's always positive. Now, how many hydroxides are there in that compound, Alyssa? So what's the charge of a hydroxide? So what must the charge of the ammonium be? That's right, positive 1. And what is the other ion? OH, what is its charge? Okay, that's all you have to write for part A. That is the complete dissociation. Riddle me this, bonus question. Is that an acid or a base? How can you tell, Nick?
Because of hydroxide.
Say that again.
Because of hydroxide.
Because it has hydroxide, it's basically screaming at you, base! Now, here's my second question, bonus question. Is that a strong base or a weak base?
Strong base.
What makes you say that?
Because it dissociates.
Did it really? Look at this guy. Is that monatomic or polyatomic? It's polyatomic. And when you have the other ion, the one that doesn't indicate if it's an acid or a base, is polyatomic, what does that mean? It did not completely dissociate. So is that strong or weak? This infers that it is weak. This infers that it is a base. I want to make sure you guys picked up on that. Yes, Arshan?
If the NH4 did dissociate, would that make it an acid?
No.
Why? Because then there'd be more
Okay, your hypothetical couldn't happen. It's polyatomic ion is one unit. It's all one thing. Okay, so let's look back at the other question being asked for this one, if I can find it. Here we are. Find the pOH of 0.0278 molar ammonium hydroxide. Find the pOH of 0.0278. This one's simple. What would we do? Carson?
We're going to do negative log,
Negative log, go on.
and then you do 0.0278.
Yep. I do have my calculator with me. Negative log, 0.0278, close parentheses. Maxie, what'd you get?
1.556.
Let's just make it 1.6. pOH is 1.6. So, bonus question number 3. With a pH of 1.6, would that be an acid or a base? pOH, David.
That would be a base.
That would be a base. Yes, Arshawn?
Okay, so since it's asking for concentration, isn't it asking for pOH? You have to use the concentration of the hydroxide. Like, you could change it at all for other problems too.
If it's asking you for the pOH of whatever substance, and it was asking you, for instance, the pH, you would have to do, you would have to find the pOH first, then do 14 minus whatever. But if it's for it is asking for ammonium hydroxide, is it not?
It's
No,
ammonium hydroxide, so the concentration isn't including ammonium. So
Like,
we
yeah.
have to alter that.
No, that's ammonium hydroxide is the base, and that's going to have the pOH.
So you don't have to convert or anything if you're okay.
So
No.
it's not just the concentration of the hydroxide.
No.
ions, it's the concentration
It's the whole thing. Ammonium hydroxide is the base. And you guys are seeing stuff that's not there.
Well, because when you say the concentration of hydroxide ions, then you would put like the concentration of hydroxide, not concentration of ammonium.
But the whole compound is basic. If you put ammonium hydroxide in water, and hydroxide ions come off of it, that suggests the entire compound is a basic compound. Okay? If you put something in water and hydrogen ions come off of it, then that means that whole compound is acidic. Yes, Carson.
In these equations, in these questions, why does it give you like the liters?
I'm going to get to that. We're not there yet. Slow your roll. So he does bring up a good point, which you stole my thunder, kid. You never steal Thor's thunder. So I want you all to check out part B on number 2. And I want to tell you what you need to do. If you can all please look up at the screen, really take this in. So Carson's asking, why does he give you liters? Well, I want you to look at this. Look at this old pyramid. See if this rings a bell. Whatever you're trying to find, you cover it up. So you see that you have 4.34 grams. And you have 2.25 liters. Well, grams per liter is density. Is there a way you have 4.34 grams of sulfuric or carbonic acid? Is there a way to find the moles of carbonic acid? Yes. So what you need to do, and I'm not going to do it for you, you need to find the molar mass. I'm just giving you the instructions. And once you have that molar mass, you will convert from grams to moles. So what resource will you need to do numbers 2, 3, 4, 5? You need a periodic table. Now, once you have moles, you can do moles divided by liters. Are you given liters? Sure you are. It's 2.25. And what is the answer measured in when you do moles divided by liters? Molarity. And it wants to find the pH. How do you find the pH from molarity? You will do negative log of the molarity. So that's a lot to take in. So I'm going to go through that once more, and then you guys are going to be on your own. So if you need that broken down for you one more time, I'm happy to do it. Let's switch over to your notes. Number 2 says, find the pH. So that's what we're looking for. We don't know what it is. Of 4.34 grams of carbonic acid And does it says 2.25 liters of solution?
Yes.
Okay. All right, here is what you need to do first. I'm breaking it down for you so simply. Step 1, convert grams to moles. How do you do that? Derek was quick to say it. You need to find the molar mass and convert like you've been doing for weeks. Step 2, once you have your answer in moles, you need to do moles divided by liters. And what will that provide you? What will that give you? Molarity. And then to find the pH, you need to do negative log of your molarity. And that will give you the pH. If you're not sure what type of math to do, remember this. Moles over liters times molarity. You cover up whatever you're trying to find. If you're trying to find moles, cover up moles, you do liters times molarity. If you're trying to find molarity, cover it up, moles divided by liters. If you're trying to find liters, do moles divided by molarity. You guys are welcome to work together if you like. You're also welcome to work independently. Francis, coming up here, I need you to make up your vocab quiz Monday before or after school. Here's what we're doing. I'm sure Juliana could help get you up to speed, or Arshawn, or Nicole, or Derek, or any one of them.
Could I come next period to take my vocab?
This is going to be a full class, so I don't have anywhere to put you.